Well, I felt like yes. For me, I feel like yeah. Yeah. Well, and I think I understand. By the definition.
Okay, let's start. Okay, so I suppose you already started to looking for your teammates in the group. If you haven't started to do this, do it now. By the end of this week, you need to finalize your group. Okay, so this lecture, we start to talk about the technical part. As I told you, the first part will be more on the computing system part. And then we will go to like a web structure that's a little bit math involved. And then the last part, we go back to systems as well. Not the system, the application software systems. Okay. Right. So now we heard a lot of things about the big data and AI. Right. I use the slides for quite several years, but it seems that's still the feature of the technology, right? So something they started to have is this kind of autonomous driving cars, which I really hope we can get it in the near future, right? Because I live a little bit far from here. It's roughly 1 hour drive. So if I have this 1 hour, I can do my own stuff. I don't need to. That's very stupid, right? Just sit there, and it's also dangerous. So others like AlphaGo, this is also very impressive. Basically, there are many aspects that is impressive. Of course, it beats all human beings easily, right? We start the questions of the art, something we call art, whether it's art or just mistakes, right? So I played the game. So previously, when the human professional players, right? When people play the game, there will be other two people there to just explain what happens there, right? In the old days, whenever they feel like something seems not right or something they cannot explain, they just consider it as art, something they can. But now with AI, because AI just directly give you a number, that is the probability of winning, right? So if you play this move, maybe your winning chance is 60%. But if you play wrongly, then it can directly go to like 20%, right? Now, if we use that to replay what happened in the past, we can see in many cases, something we call art actually are mistakes, right? So they just did very poorly, but they have no way to explain it, so it's considered as art, right? So nowadays, when they basically explain the situation, they now use AI. Whenever they cannot explain, they will look at what's the chance, winning probability of AI, right? So that's why area change a lot. But meanwhile, something actually surprising to me is that even AI can play significantly better than any human being nowadays. Those fundamental principles of how to play, right? Those principles, as a kid, you learn, still stay the same. That is quite surprising, right? Because you may expect that AI is much better than human beings, so it must play in a very different way. No, it's not. It's actually in the very traditional way, right? In the sense of some very famous Go players that almost a decade ago, they already predict some moves that align with what AI are doing now. Right? So this gives us both the challenge and the hopes. And the challenge is that, you see, right? This why AI can easily beat human being. But the hope is that there are some moves. At that time, they don't have the such a large computing power and model to help. Right? Just thinking about that, they can actually make the right choice. And it's very hard, right? Because you know, on for the play Go on the board, there are so many options you have. And nowadays, the top human players, they use AI to train themselves, right? So the top ones, in the first 20 or 30 moves, they can do exactly the same as it. Right? You can imagine each move, you have over 100 choices. And it's exponential, right? So each time you make the right move, so that is also impressive. And AlphaGo Zero is something that at the beginning they use supervised learning. Right? They have a human player as a training data to train the model to play, and then improve the model using reinforcement learning. Right? AlphaGo Zero just remove the first part. Directly come from reinforcement learning, and it easily beats the previous version. Right? Because right now we understand why. Because we made a lot of mistakes as human players. And if you use that as training data, you may stuck in some very poor situation. Right. Okay, so but nowadays, of course, we have ChatGPT, right? That's more, we will talk about that later. Right. Okay, the question for us now is that whether big data and AI is the future, right? So now probably many of you believe it's the case, including me, right? But when I first asked the question 5 years ago, it's not that clear. Because at that time, we don't have ChatGPT. Before that, yes, there is AI, but we don't know how AI can be useful. At that time, we already have Transformer. But no one knows how to use Transformer 4. Right. So at that time, NVIDIA, the GPU, the most profitable use case is actually cryptocurrency mining. Right. Versus what happened now. So just every year, change a lot. But now still, right? Looking back into the history, it's still has a lot of value. I think in the AI era, one area our human being can do better is look into the history. We probably stuck too much into STEM, into the technology. But now we start to realize that technology-wise, many areas AI can do better than human being at a very low cost. Right. So what's left? It's probably we go back to those literal arts, right? Liberal arts, right? Those liberal arts, they are serve at two purposes. One purpose is that once you have the tool, how to use the tool actually is not a technical problem. Like even now we have autonomous driving, but how to use it, right? It's not a technical problem. It's also involved in a lot of philosophy debate, and we will say that, right? So how much human lives, how many human lives can we sacrifice, right, in order to have the system running? Those kind of questions is not a technical question. And also, even for the future, when we have AGI, right? So there is one theory, right, saying that with AGI, the productivity of society will grow a lot, but many people will be out of job, right? Then people start to propose, like both in Canada and in US, the president candidate, they start to propose something called the UBI, the Universal Basic Income, right? Means that since we have enough produce, right? So we have enough food and shelter, right? We just give everyone the basic cover, right? Then whatever you want to do, that's your problem. That's your question. Right? But at least you have food, you have shelter, you have the basic needs. Right? That at the beginning, I think it's several years ago, also before ChatGPT. At that time, people consider the idea as crazy, right? So, but now I think more and more people start thinking that seriously, right? Including like Elon Musk, right? If you look at the video, right? When people ask them, with AI, what can human do? I think he thought for a long time before giving any answer, right? And eventually, I forgot exactly the word he used, but he basically saying you should do what you like, right? So because he is at the frontier of the AI industry, right? Think about Tesla is not just a car maker. They actually have autonomous driving, a very successful deep learning application. Right? They also have robotics, right? And they have also AI, many different things there. Okay, so that's important because when we look forward, it's always hard, right? But when we look back, everything becomes so clear, right? The question is try to bridge this two. Make it not that clear when you look back to the history, because you don't want to look into the backward mirror, right? When you look at the history, you want to put yourself in the similar situation, and also predict forward. That can help us in doing that. Right? So prediction also is very, very hard. Right? So there was a famous saying. So for those who predict the future, either he doesn't know, or he, I forgot the exact word, is just basic stupid, right, to do that. Right? So because predicting is so hard, right? Look at, right, those doing for presidential election, right? A lot of prediction, but most of the time it's wrong, right? So it's worse than the bet. Very dangerous because sometimes it just starts automatically. Okay. Also, financial market, right? You see the hedge fund manager, right? Especially those based on fundamentals. Right? I think they did a test. Their guess is worse than random. Look at the Federal Reserve, right? They have thousands of economists. Look at their bet, right? Their prediction. I think it's worse than normal people, right? So prediction, I think we can safely say, unless something fundamental change like AGI suddenly has a power, right? Prediction is hard. Right? If you rely on your decision on prediction, then good luck. Right? But instead, what you can do is that there are always some scenarios or some possibilities, right? You should base your decision on those different possibilities. And some are good for you, some are bad, right? But you should be able to survive in most cases. Right? So that is a more useful way, right? Basically, don't predict, but learn from history. You are better in thinking about the possibilities, and also think about your decision or strategy under different scenarios. I think that is more useful, right? Look at the financial crisis, right? The problem is that they just always think about the best scenario, right? If they think about a little bit of even the normal scenario, they probably won't do that, right? And now you say the financial market, the stock market all again goes into the top maybe 7 or 8 companies, right? It happened in the history, right? Not just once, right? So every time it's, right, the ending is not that good. Right? So look at back into history, right? Because if you just look at now, you feel like those big companies is basically it's not defeatable, right? So it's like the company will be there forever. But think about that, right? Many companies like in the old days, like IBM, like Intel, was considered as a company that is not failable. But look at the situation of Intel now, right? Even the chip industry is so successful, but the performance of Intel is not that good, right? But think about Intel has been there as probably the biggest successor, the player, right, for decades. But even though, right, so that's where we can look. Okay, let's start. Do you know how old is the internet? Anyone?
49 years, 40. Talking about the World Wide Web or just like, these university sort of intranets from the 60s?
Let's talk about the basic idea, the first proposal of the internet. When is that?
Like 60s, right?
It's even earlier.
Oh.
But think about that. If you are lucky enough to have the proposal, right, you need to wait several decades for it to have the minimal implementation to come true. Right? So the basic proposal is that when we store information in books, it's a linear, right? But we want to create like a web, not just linear. This is our brain, how our brain works, right? Our brain is not linear. No. It's also we want to survive a nuclear war, right? From the physical infrastructure level. This is after World War II. At that time, the communications, they realized the importance of communication, right? But at that time, they use a telephone network. A telephone network is that each city, they may have a central switch center, the hub, right? But the problem is that if your enemy basically destroy this center, so all the city is out of communication. So it's very fragile, right? It's a single point failure. But now the internet is that it has the router, for example, for America, across the country, right? So you need to destroy a large fraction of them for the network to stop working. Right? So, but luckily after that, they don't have the chance to test it. Right? So there was no nuclear war. Right? But we can imagine if there is a nuclear war, right? So many of us may die from the nuclear war, but the internet may survive. Right? They don't need many, they just need several routers they can survive. Right. And another one at that time, Metcalfe. So he recently also got the Turing award. Right. So it's a Metcalfe's law. Right. That was the one. I remember this very clearly because that was the law I learned as a master student in my first semester. Similar, yeah, similar to you guys. But at that same time, I'm learning economics degree. So there was a question like whether a larger population is actually advantage or disadvantage. Right, depending on which country I'm from, depending on your education, right, you may have different answers. Right. But at that time, I basically write the essay based on this one. Right. You see this one. The value of the telecommunication network is proportional to the square of connected users. It's not linear. The reason is that when you come to the system, your value to the system is proportional for the number of users already there. Right? Therefore, the marginal benefit is proportional to number of users. Therefore, the total value is to the square of this one. Right? But if you think further, right? If the system, the value is square to system, but to the physical need for human beings or for population is only linear. Right? What happened is that the cost is linear, but the benefit is quadratic. Right? Then the result will be larger population is better. Right? Actually, later, not just for internet, right? For e-commerce, for our economic system, it's also like this. Right? If a system only have several people, like if you look at the movie, if there is some crash of airplane, you're stuck on some island, right? This is so hard, right? Everything you need to start very, right? But look at the scenario we have, right? Especially if you compare the country like the US, very advanced, many products you have is from all over the world, versus a country in Africa. They basically need to rely on themselves, right? You can clearly see the value, right? So, given this one, larger population actually is an advantage, right? So, which we actually start to see that, especially in East Asia, right? So there are several countries have a very low birth rate, right? It actually has a very big impact on the society, right? Because when you don't have enough people, then everything you build will be an issue, right? The economy actually start to grow very slowly. So even though they propose it very early, but it's very important. Now, e-commerce, like something more related to applications, right? So now to decide whether application will become successful is the number of users. Right? Very different from the Wall Street standard. And the Wall Street, they don't care about the normal user, right? And the big players. And the Wall Street, they need to see the real profit, not just the number of users. But look at what happened in the past 2 decades, right? You compare Silicon Valley with Wall Street. The winner is very clear, right? Right? If you look back, look at many companies, how they become successful, like Facebook, right? For a long time, Facebook have no idea how to get the value. Right? The business model is unclear. But they believe that in the user, as long as you have more active users, you should have the value. Eventually, they find a way to commercialize, right? The idea to get the money back. Right? But if in the Wall Street standard, the company won't exist because they keep burning money for many, many years. Even now, many successful companies are still burning money, including OpenAI, right, for ChatGPT. Right? Why? Because you need to believe in the value of users in order to do this, which could be wrong in many cases. Right? But once it becomes successful, because the user base is so large, for example, Facebook, the user base is at billions, right? So they created the value is so large, also change over basically how people communicate. Right? Of course, there are new kind of applications. Okay, this is a starting part. And after more than 20 years, they start to build the prototype. Right. The prototype at the beginning is like 4 nodes. I think UCLA, University of Utah, and the UCSB. Actually, at that time, they asked Caltech to become one of that, and Caltech refused that, saying that meaningless. Yeah, so it's hard to make the right decision, right, at that time, right? Because you can imagine to build a 4-node prototype, right? We are doing many more experiment or prototype larger than this one at this moment. Look back, of course, you know this is the most important one. But think about among the thousands of prototypes we are doing nowadays, which one will be successful? It's so hard, right? And but one good news is that within the following 8 years, it become larger, and they call it ARPANET, right? ARPANET is funded by DoD, Department of Defense. And you can say from the beginning, the idea is that I want to survive the nuclear war, so it's related to defense. So they funded it. Because it's funded by the government, the good news is that you don't need to worry about your profit. But the challenge is that it's hard to find users, right? Yes, you can invest more money, right, to build the system, but who can use the system? Okay, think about what is the first killer application on the internet? Wikipedia. Anyone else? You guys are so young.
Like instant messaging,
It's a message.
blogs,
Huh?
blogs.
Blogs. Okay, what else? It's email. Why is email? Because it's simple, right? Think about to develop an application like email versus develop an application like a Wikipedia or others, right? So which one is easy? Right? Email is just, think about now, if you want to develop email system, what do you need? You need a destination IP, right? Because the router will just send it directly there, right? The physical link. And then what you only need is that I have a packet. I just put content in the packet. That's all. Put it there, you get it, right? But to get Wikipedia, you need to do a lot of things, right? Before it can work. So once they get the email, right, basically they start to have the TCP IP. Basically, this one is used for congestion control. Right? Before that, there's no congestion because no one uses it, right? Yes, we build a network, but how to use it, right? But once they have email, again, we are already very used to email, right? So we forget the importance of it. Right? Think about in the 70s. Yeah, you guys are too young for 70s. But try to imagine, right? You probably watch some movie or TV series about the old days, right? For your parents, basically, you can go back ask them, right? When they were young, if they need to communicate with others, what can they do? You need to write the letter, right? And then you need to put on stamp. By the way, the stamp may not be that cheap, right? Because you need some human to collect and send it along, right? And then you wait for maybe 1 or 2 weeks, right? Until you get the feedback, get the response. Right? In many cases, if it goes no, you have no idea, right? Whether they didn't send back. Or in some cases, your parents don't want you to have the communication with them. They just keep it, right? That's a very popular storyline, right? Basically, that means the communication is not reliable, right? And you cannot tell whether it's reliable or not. Of course, the most advanced one now is quantum communication. Quantum communication is not just reliable, and it's also very private, meaning that even someone try to hear what happened in the middle, you can tell. It's not just you steal the letter, even you watch the letter, I can. But in the old days, it's not the case. right? If you go further in the history, right, communication is always an issue. Because in the old days, people die easily. And therefore, that's why you can understand why in the old days, like several hundred years ago, when two people, I mean, one people want to go to another area and they say, basically say goodbye to each other, that goodbye may become the farewell. Right? That's why there are a lot of poem, a lot of other essay or something about that. Because it is something critical. Not like now, right? Say bye bye, and then you have the message, you have all the supply, right? In many cases now, you even didn't see them in person, right? You just rely on that one. Even you live in the same house, right? You still use the instant message to do the communication instead of talking, right? So it's changed. But that's why you need to think from the old days. So at that time, people realize, oh, I don't need to make the phone call. It may be costly. And you need to make sure the other people is there. Now you can just write a message, email, right? Can direct get there and get the feedback very quickly. Right? So many people, especially the network, most of them are university, right? Then they have a lot of things they want to communicate, so they have a congestion. And the TCP protocol is basically for congestion control, and the IP is for routing to find the shortest path. Right? Both become very useful when the network become larger and when the demand is larger. Right? So basically, you can say for a successful system like this, it's not successful by design, because by design, no TCP/IP, right? It's just infrastructure. Once there is a need, they start to get a solution, and it's very successful. Right? Another note about this one is that the current internet architecture is actually developed by itself from bottom up. Right? Like this, whenever there is a need, they try to get another layer or find some patch on that one. Instead of we develop something at the beginning, right, which is not which actually happened. There was a protocol architecture called OSI, developed by ISO. And so they just got a name, right? So in that layered architecture, they have 7 layers. Each layer has a very well designed protocol for each layer. They even have layers that the current internet does not include, like for security, for privacy, for those ones, right? Which is very needed, right? Think about our internet, the security issue, right? But the reality is that no one uses that. Even though they put a lot of effort, they even call that the standard architecture, but no one uses that. The internet just derived by itself, right? Our current architecture have 5 layers instead of 7. So the other 2 layers just, so this is also the case, less is more, right? And based on this simple architecture, right, later, you say they develop all the technology, right? So after a while, the next one they develop is a domain name service, right? So this is not an app, actually, but it's a very useful. Basically, now you can just use, for example, the search engine history.com, right? But at the beginning, you need to remember the IP address. Right? Like remember the telephone number, right? I think at that time it's okay, right? If you can remember other people's telephone number, you can remember my IP address. But after a while, people say, no, there are too many of them, right? And let's just do this one. So that's why you have the domain name, right? Even though it seems natural, but this is a big business, right? Now, if you have the domain name like AI.com, right? You probably can sell it at a very high price, right? For example, in China, I think the story of Alibaba, they wait a long time and eventually bought the domain name, right, for a significant amount of money. Right? So I think now it's still a big business. You basically try to guess what will be the next popular domain names, right, and buy them at a low price.
Actually, a fun fact, before Jeff Bezos converted Amazon to Amazon.com, he used to be a bookstore, so he had it called relentless.com. And if you type relentless.com today, it takes you to Amazon. It's still under their domain.
Yes, so actually there are a lot of domain, they can do the HTTP redirect and guide you to the new one. So basically that means that you can still make money from there. Maybe some people are use large language model to do that nowadays. To guess which is one. Actually, I know some people are doing that. Still very successful, very profitable. Right? Because not many people are doing that. Okay. So after that, people develop browser. Right? So now this is eventually the step going from the linear information to semantic information. This is that. And at the same time, they have the World Wide Web. Also, again, now this is a very famous conference. But at that time, when they submit the idea to the conference, they only get a poster. They didn't get accepted to the main conference. Another to highlight how hard it is to tell which idea will eventually become successful. I think if they look back, okay, later probably is something you are familiar with, right? So Yahoo story, very sad story, right? If you are familiar with this one. So Yahoo easily get very famous, and in the dot-com bubble, it also goes hard and then start to go down. But at the peak, it has hundreds of billion dollars as the market cap. Right. But they miss many opportunities, including Google. Right. Google at the beginning, because the two founders of Google at that time was a PhD student at Stanford. Right? You know, as a PhD student, you somehow believe research is the most important, right? Which may not be true, right? So, that's why what they want to do. They want to sell the idea of Google to Yahoo at $1 million. Right? Again, Yahoo spent billions of dollars buying a lot of companies, but they refuse this one. Okay, this is what happened, right? So the founders, they have no other way. They have to drop out, right, and to start a company. At that time, I think the Google, we will talk about that in more detail later, but at a high level, Google become very successful because I am old enough to use Google versus Yahoo at that time. So I can tell the difference. I still remember the first time I used Google, right? It's so different because at that time, if you want to go to Yahoo to find some information, all the information on the first page, right? They probably only have one web page. The web page can go through 50 screens, right? Then you need to scroll down your mouse all the way to find the information you need. Basically, you are doing the search by yourself, right? And Yahoo just put a lot of information on the homepage. And then good luck, try to find what you want by yourself. But this is the interface of Google. Right? This is a real search, right? I just need to put in and get the result. I don't want to go there. Right. But this highlights the difference, the underlying both the design, philosophy, and also the techniques. If you don't have the technique, you probably want to put what you think are most important on your first page. Right? Because at that time, the technology is that there are many search engines. There were many search engines. But if you use a search engine to search for itself, right, most of them cannot return to its own website. Right? That's the quality at that time. Right? So for Yahoo, it's not like they don't know this is better. It's like if Yahoo also use this way, you cannot get what you want. That's why they put everything on the first page, right? If you cannot get what you want, it's your fault, right? It's undeniable. Right? So then you can realize very quickly Google dominated the search end to end. And Amazon, right? So Amazon, the interesting part is that first they started with a bookstore, right? Kind of an online bookstore. And then they go everything online, right? They even create a cloud computing, right? Cloud computing was basically they have the server there, no one use. So they think about how can we make use of that? And you say that is a business idea, right? Because the Bezos is from the Wall Street, right? So the business idea is that if I can, let's try to make more money, right? Google is very different, right? Google data center is even low utilization. They just leave it there, right? So nobody cares, right? Because they feel like I have enough money, right? So they focus on the most important part, right? So you can see even nowadays, later we may have a chance to compare Google's product, the Gemini with ChatGPT. You can still see the difference. Many Google products are very good in the technology, like a transformer, right? Google Glass, right? The autonomous driving, that's a company of Waymo, right? Very successful in the technology part. But when they go to the product or the content part, yeah, that's really hard. On the other side, like Amazon, they do very well, right? Customer service, the experience. That's why AWS for a long time is better than Google Cloud. Right? Google Cloud, they actually hire tens of thousands of people. They build several buildings, it's almost a campus in Mountain View for their cloud computing. And also technology, right? Basically, Google developed cloud computing. They have all the way from infrastructure, hardware, software, everything they have. But it's just not successful from the business perspective. Right? And recently, they actually go to the real world, right? So they purchase Whole Foods, right? You start to see some difference here, right? Facebook, right? Facebook changed the name to Meta, right? There's a long story behind that. Right? So that is one direction. Maybe something that you are interested to do in the project. Twitter, also a long story right, behind this. Netflix, again, long story. Yeah. So each one, right? So like also Uber, right? Uber has been represent the new technology, right? But now with autonomous driving, the company may become the kind of the bottom, not the bottleneck, basically the block, right, on the way, right, to autonomous driving. Because Tesla, if they have the robot taxi, right, so when the business model from Uber may be killed. Right? So you can see it become faster, right, the technology value. And also this value is outdated, but generally speaking, except for like Yahoo or some other, right? So all the companies go very quickly, right? In terms of not only the market cap, but also in terms of this profit, which is the most impressive part. Because if the company only has a market cap, it may be a big bubble. But if it's supported by the profit, basically the P/E ratio for Google nowadays is not that high. Right? So that means they create a lot of sense, right? Of course, Bitcoin is another story. If you look at this one, this is a line that's very hard to say, right? That's like the number of users, right? But at the same time, the value in a cryptocurrency like Bitcoin heavily depend on the number of users, because there is no inherent value in that one. It just like money, the more people use it, the more valuable it is. Okay. Behind this success will be the huge amount of data. Right. So number of web pages, right? You can see how quickly they increase. And nowadays, even Google have no idea how many pages there are. Because in order to know the current web structure, you need to have the crawler to crawl all the pages. But the number of pages created is at a much faster rate than Google can crawl and can store. And there are a lot of dynamic web pages that you cannot crawl. Because every time you crawl, it has different content. So, but basically you can think about the trend, right? So how many pages we have, right? Definitely several magnitude higher than this one. Okay. So this gives us a huge amount of data. But on the other side, this huge amount of data seems small in terms of large models. Because you probably all heard about that, like the ChatGPT training or Google Gemini, they already use up all the text data on the internet. Right? So think about the small and large, right? They change, it depends, right? It's definitely a huge amount of data, right? How huge, right? For Google, they need a building like this, just store the data. It's huge. But on the other side, for the large models, this amount of data is not large enough. So that is the problem. But to generate the internet data is also time consuming. Right? It's all the internet users like us, right? You work every day to generate the internet data. Right? Using AI is easy, but the quality of data, right? You may create a cycle, and that may not be good. And also the other one is a load. The load on the first web server, you can see it's also, the y-axis is exponential. Oh, not exponential, it's a log scale, sorry. So basically means it's going exponentially. Right. This is also, right? So the question we will talk about later in the course will be, given such a big network, right? Especially now we have no idea what the network exactly is, right? So what kind of property can we say about the network? And why does this network have these properties, and how can we utilize that? Right? That is what we will discuss later. And now we come to AI, right? So AI is also been there for a while. Later we will talk about the history of AI. But before this week, right, I think when you grow up, you definitely heard more than one time about AI. Right? So this is not the first time AI is in a bubble. It had been there for several times. Right? So what is the reason, right, or factors enabling this round of AI? Right? So basically we can say at least there are three of them. The first is that for the first time, we have big data. Right? In the old days, say, even you have transformer, the neural network architecture, even you have the GPU cluster. But if you were just 20 years ago, right, with only limited internet data, you probably still cannot do it very well. Right? So the big data is really large, right? For the text data and also in different ways, right? People start using the image, audio, and video to train the network. But you can imagine the problem with the video and audio is they are not labeled. Right? So the data is large, but it's not that the quality is low. Right? So that is one area people are working on, like semi-supervised learning. Right? This is a very hot area. Right? So giving you a lot of video, how can I do that? Actually, the deep learning starting from Google, right? In year 2012. Right? Yes, that time I was doing internship with Google. Right? but not with the AI, right? Because at that time, I'm stupid enough not to realize the importance of AI. But I can tell you what happened. At that time, they already have YouTube. A lot of people update YouTube video, right? So they build, at that time, I believe it's a CPU cluster to train a neural network. And it's unsupervised learning. So just let the neural network to watch a lot of video. And eventually the neural network can recognize the animal. Guess what's the animal? Cat. Yeah. Because probably at that time, a large fraction of video is about the cat. Probably still the case, right? But think about this one, right? Look back, very clear, right? This is a breakthrough, right? Unsupervised learning. They already test a large-scale system, even though it's CPU. And also, the neural network, they already showed the power, right? Even though not transformed. But since I experienced that, I can tell you, at that time, it's really hard to see the future, right? Because yes, it can recognize cat, so what, right? And even Google didn't realize the meaning of that, right? So that's why nowadays we have OpenAI, we have Microsoft driving this round of AI, right? So that's what I mean, right? Looking back, so clear, right? So each milestone. But if you were part of the history, then you realize how hard it is. Because this is just one news in my life at that time. There are many other news, for example, cloud computing. That seems more important than this one. This one just like a toy example, right? You recognize cat. Okay. Big data, big systems. That also started around like more 10 years ago. Right? In the old days, right? If you want to, even you want to do the large scale computing, what can you do, right? Either you use Linux or you use Windows. Mac OS, right? Not very useful. Use this too. But if you do Linux, you need to write the code by yourself. Right? I know my mentor at that time told me the story. When he did his PhD at Yale. So he also need to process a large amount of data. But at that time, no Hadoop. So what he can do is that he can manually, write a script to divide the data into several pieces, right? And put each piece on a server. And then after a while, get the data back, result back, and merge them, right? It's actually memory reduced, right? But at that time, no such thing like this. So you need to write the code by yourself, and you need to handle the failure by yourself, right? If something goes wrong, okay, redo it, right? So you can imagine it's not very convenient, right? On the other side, if you use Microsoft software, maybe they can do something for you, but it's so costly, right? Later we will click that link, you can see, right? And each copy is very expensive. And if you do enterprise level, they charge you even more, right? So the problem is that if you have 1,000 servers, in the old business model, you need to pay millions of dollars just to have the operating system, right? But now, right, you know the solution, right? You get Linux and then you get Hadoop, that all free, right? If you want to do machine learning, okay, Kubernetes, Spark, all of this, everything is free for you to use, right? The last one is economic for accessibility, right? Think about Google at that time. I think they use millions of CPU cores to train the network for maybe 1 month or something like this. Think about, for us, if we want to do that, it's almost impossible. So what do you need to do? You need to first find the physical location, find a room, right? Can host your server, and then get the power, get the cooling, get someone to take care of your server, and then buy the server, get them shipped, install everything, right? So you may spend millions of dollars, right? And a lot of time before you can actually run the system. Right? But now, right, let's click this one. Share this part. This is a okay, here. This is a Amazon EC2. First of all, you say if you haven't used it before, you can get the free results by just registering yourself. You can give a try. And then let's say the pricing. Basically, they have three ones. One is on demand. On demand means that whenever I need it, I can get it. I can, for example, I reserve it for 10 hours. For these 10 hours, it's all mine. It's always available to me. They are saving price, means that if you sign a long contract with them, they will give you a discount. Makes sense, right? And the last one is called spot instance. It means that you say, I don't want to spend a lot of money. I have a budget. But I also are flexible in when my job can be finished. So when other people don't use a system, you can serve my job. If they want it, you can just pause my job. Right? This is very useful if you are doing a training, right? Because training, you can easily do a checkpoint. Right? You just store the current parameter. Next time, just resume from here. But at the same time, you can save the cost maybe up to 80 or 90%. Because when other people don't use it, right? If they don't sell to you, it's just a waste. Right? The marginal cost for them is just probably just electricity they pay. And even for electricity, now in California, during night, you may see the negative price because they just create too much during that time, and not many people using that. And so give them further incentive to do that. You see a lot of business behind it, but the on-demand is the most popular one. Let's say on-demand pricing. Basically, you can choose a location. Later, when we do our assignment 1, you will do that in a non-profit cloud platform called Cloud Lab. So it's sponsored by NSF, basically by the government. So I think this is probably the right use for you guys to use that for education purpose. So there you can use it for free, but of course it's not as well supported as this one, and this one you need to pay. Here you can see you can choose different locations. Right. Now probably it knows my IP address, or by default it's US East, but you can choose many different areas, right? In different countries. Right. So this is the region, and you can choose the operating system. Right? Linux is the cheapest because Linux itself is free. Then you can see there are different types, right? Let's say if it's a general purpose. Let's say there are 200 of them from a very cheap one. Right? The first one is very cheap, probably not very useful. Right? Maybe let's talk about this one, the small one. The small one basically costs you like close to 2 cents per hour. Right? So every day you pay like 40 cents, something like this. Right? So it's very cost effective. But the downside is that it's very small. You only have 2 vCPU. vCPU can consider that as a kind of a low-end CPU core. You basically have 2 of them. Memory, you have 2 GB, very small, right? But if your application is don't use a lot of memory, you can do it. And storage, you need to add more storage. And the network performance is up to 5 gigabytes. But that's a problem. It's up to. Basically means it can be arbitrarily low. Right? And if you want to do something larger, for example, something similar to my laptop, it's probably this one. Or this one. Yeah, probably this one. Then you pay like 13 cents per hour. Right? It's more expensive, but you get more CPU cores, more memory. But the network, you see, that is a hard one to get. If we go deeper, let's say if the last page, this one, you start to be more expensive, right? $4 per hour. But now you get a lot of CPU and memory. For memory, I bet your computer don't have this amount of memory, right? And the benefit of for this one, you can run the large language models on your computer. Right, the large model normally require like a 40 or 50 gigabyte of memory. The normal computer cannot do it. Right, but there you can run it. And here you see the network performance. Now they give you 100 gigabit. Right? Basically, they start to guarantee you the performance. Before we go to other purpose, let's say if I choose a different one, right? Guess which one is more expensive? Oh, Windows, right? Which Windows? Yeah, with this one, right? Let's see. If you choose this one, again, general purpose. You see? First of all, no smaller ones, because the smaller ones cannot run Windows, right? That we know. But the large ones, recall that I just said a large one like a 8 or something between these two, right? It's probably 1/10 of the cost. But now you see the network is still very slow. But because they use that operating system, this is how much you need to pay. And the money is not belong to Amazon, right? Most of them go to Microsoft. That's why Microsoft is still very valuable, right? But I can tell you that because the cost is so different, right? A lot of development nowadays is based on Linux, right? Because for Linux, they also have the if you do the traditional Linux with also the database support enterprise, right? For this one, it will be a little bit better. Actually, not that bad. Let's try this one. Similar. Oh, this one is, they have this very large one. But what does that mean? That means probably it's not just the problem from Microsoft. It's also the database. Right. So that's explain why a company like Oracle, right? Oracle hasn't developed new technology for a while, but they still work very well with a lot of profit. And you see, which also means if you work on developing a database system, that could be a very good area because you see the profit margin here. Right. That's why there is a lot of non-SQL database developed over the years. Yeah. So I know if you're not rich enough, right? So normal people will do is that I just use Linux and then I use some free database. There are some like MongoDB that work very well, and together with the big data system. Right? Okay, there are also other purpose. Instant type. For example, in some cases you want to do compute optimize, right? So the computing they have those good ones like this one. They can have almost 200 CPU cores for your computing. Or if you say I want to do memory, this is probably the memory, right? You see this one? Well, this is super large. You can see those memories, they can give you this amount of memory. And the accelerated computing, that is a GPU, right? So let's say the large ones. Yeah, this is not that large. Yeah, these are actually not that bad, right? So I guess it's no GPU here. Right, they just give you more. Let me check. This is for storage. Let me check. Whether they have a GPU. This is their GPU instance. So actually, there are some company doing that, trying to across multiple cloud, and trying to get you the cheapest one for your computation, right? So a lot of startups are doing that. Okay, this is the GPU instance. Let's see if I can find the price. Okay, so here is a price. This is a single GPU VMs. So that basically means that there is a single GPU and you only do a fraction of the GPU. Actually, like NVIDIA, the new GPUs have something called a multi-instance, I forgot the name G for, it's MIG code. So basically that allowed you to run similar, like a multiple virtual machine on the same GPU. This is probably something like this. You see it's one GPU, but it may not be directed to you. And you can go to multiple GPUs, depending on large or basically, I think they all have the smaller ones. Yeah, that makes a lot of sense because the more expensive ones probably is you need to compete to get access to it. Because the company itself, they also need to use the GPU for their own purpose. Okay, so now let's give you some experience about the cloud computing, right? So back to this one. So this is the three part. Right? Now we have a big data. You can see the even for the memory, right? It can be very large. Systems, you can see if you have to use those from either database or the operating system from traditional, they charge you a lot, right? But all those are free. And this one now, you don't need to build the data center by yourself. Right? You can directly pay. For those ones, if $1 already get you a fairly decent instance, like $1 per hour, then you get 1,000 of them. $1,000 per hour. You run it for 10 hours, it's just $10,000. It's a very small fraction. You can already do a lot of work than before. Right? So these are the three reasons why we have this round of AI. Right? You can see the AI, like OpenAI, also benefits from this big data, big system, including the transformer, right? Because transformer is open source. Google didn't charge OpenAI for using the model, right? Actually, if they know it's a case, they probably will. At that time, they don't know which model will be successful. And OpenAI, I think at the beginning, even now, they still heavily rely on cloud computing, right? So basically, Microsoft Azure providing the service to OpenAI. And because OpenAI, they don't want to manage the infrastructure, right? They just want to use the resources for their training, right? But everything else, Microsoft basically handled. As a result, right, three major players in cloud computing, Google, Amazon, and Microsoft. Right? Google has the strongest technology, but Amazon probably have the best business model, right? And now Azure probably did the best in AI, in cloud AI, right? So that's the situation. Okay, let's do a little bit more, and we will stop here. How old is AI? Give me 1 or 2 minutes, because I want to talk a little bit about the history of AI. Right. The artificial neural network, the name also comes from during World War II. Right. Unfortunately, normally the war is can create a lot of new technology. Right? Because at that time, right, nowadays people care more about the business model. It's during the war, business model is meaningless, right? So instead, you need to really have the technology, right? And after 12 years, they get the AI gets the name artificial intelligence, right? The neural network still, right? They try to mimic what happened in our brain. And the algorithm wise, the most widely used is a back propagation algorithm. Right? This one was developed more than half century ago. Unfortunately, from that time until now, we don't make a lot of advance in terms of the algorithm. Right. So theoretically, the neural network is trying to solve an optimization problem, but the optimization problem is very challenging to solve. And this one is a very simple heuristic to solve it. No guarantee, but it works reasonably well in practice. Right. But during the past half century, we didn't have a better idea how to do that. And nowadays, we use a lot of like Siri, including now ChatGPT can do the voice very well, right? But the grandparents is back to, again, also more than half century ago. Right. So they already did that well. Self-driving cars also, like decades ago, they can already drive very well. There are some video, you can search online video. At that time, even though the electronic part is very fundamental, very basic, but they can drive the car fairly well if you watch the video. Right? Again, this is probably funded by the Department of Defense. Right? So that is a case. And later is that in the game, when people play the chess, right? The chess actually beat the world champion. At that time, people start to talk about the singularity, meaning that whether AI already beat a human being. But think about that, that's more than 20 years ago already. Right. So a lot of people make an invest at that time, hoping they can reach the singularity point very quickly. But more than 20 years later, we are still not there, almost 30 years, right? That's the hard part. And IBM also have different ones. I think recent ones, they have the Dr. Watson. Try to do a lot of diagnosis, and they can do very well. And later you can see that Google has this one and DeepMind. Right. Okay, we will stop here, and I will see you this Thursday.